Welcome. In this module, we will explore two fundamental Azure compute options, virtual machines and Azure functions. We will distinguish between the control provided by infrastructure as a service and the efficiency of serverless computing. To begin, let's look at the landscape. Azure Compute Services vary based on how much control you need versus how much management you want Azure to handle. On one side, we have virtual machines, or VM. These provide an infrastructure as a service (IaaS) model where you get a virtualized server that acts just like a physical computer. On the other side, we have Azure Functions. This is a serverless, event-driven option where you focus purely on the code. Today, we will break down the what, why, and how of these two distinct services. This flowchart categorizes our two topics. From the main Azure Compute node, we branch into two models. On the left is infrastructure as a service, represented by virtual machines. On the right is serverless compute, represented by Azure Functions. This visual distinction sets the stage for understanding the trade-offs between managing infrastructure and managing only code. Let's focus first on virtual machines. When you create a VM, you are provisioning a fully virtualized computer. This gives you total control over the environment. You choose the operating system, you install the software, and you configure the settings exactly as you would on a physical server in your office. This makes VMs the perfect choice when you need to run custom software solutions or require specific OS configurations that Platform as a Service (PaaS) cannot support. However, with this control comes responsibility. You must manage updates and patches for the OS yourself. This class diagram illustrates the shared responsibility model for VMs, IaaS. The top block, User Responsibility, lists what you control: the OS, middleware, runtime, apps, and data. The bottom block shows what Azure manages: the underlying virtualization, servers, storage, and networking. This visualizes that while Azure keeps the lights on, you hold the keys to the software stack. A VM does not exist in isolation. It relies on several core architectural components. First, every VM must belong to a virtual network, or VNet, and reside within a specific subnet. The bridge between your VM and that network is the Network Interface Card, or NIC. For storage, the VM uses attached virtual hard disks, one for the operating system and optional disks for data. Finally, to secure your VM, we use network security groups, NSG. These act like a firewall, filtering traffic to ensure only authorized connections reach your virtual machine. This diagram shows the assembly of a VM. We see the virtual machine connected to its OS disk and data disk. The VM connects to the network interface, which is guarded by the network security group. All of these components sit inside a subnet within a VNet. Traffic from the internet must pass through the NSG filter before reaching the VM. Now, let's shift to Azure Functions. This is a serverless compute option, which means the underlying infrastructure is abstracted away. Unlike VMs, you do not manage operating systems or worry about patching. Azure Functions are event-driven. This means the code sits idle until an event like an HTTP request, a timer, or a database change wakes it up. This model alleviates the need to keep resources provisioned and running when there is no work to do, making it highly efficient for sporadic or bursty workloads. To choose the right service, we must compare their operational models. If you build an app using VMs, those resources have to be running continuously for your app to function, even if no one is using it. You pay for the capacity, not just the activity. In contrast, with Azure Functions, an event wakes the function. If there are no events, there is no active compute processing. Furthermore, VMs require you to maintain the environment, whereas functions manage the environment for you, allowing you to focus entirely on your business logic. This sequence diagram contrasts the two models. In the top sequence, when a user sends a request to the VM is already running and waiting. In the bottom sequence, when the user sends a trigger to the function wakes up to process it and then goes back to sleep. This visualizes the difference between dedicated capacity and on-demand execution. When should you use which? Choose Azure Virtual Machines when you need total control over the operating system, or when you are migrating legacy applications that require a specific environment. VMs are also necessary if your application maintains a long-running, persistent state on the server. On the other hand, choose Azure Functions for tasks that are short-lived and stateless, such as processing image uploads, responding to webhooks, or running scheduled tasks. Often, the best architecture combines both, using VMs for core, steady-state workloads and functions for lightweight, event-driven tasks. This quadrant chart helps map your decision. The x-axis represents the level of control you need, and the y-axis represents the operational model, event-driven vs always-on. Virtual machines sit in the top right, offering high control and always-on capability. Azure Functions sit in the bottom left, representing low infrastructure control, but highly efficient event-driven execution. To summarize, Azure provides diverse compute options to match your needs. Azure Virtual Machines offer the full control of infrastructure as a service, allowing you to customize the OS and software, but requiring you to manage networking and patching. Azure Functions offer the efficiency of serverless computing, waking up only for events and removing the burden of infrastructure maintenance. Understanding these differences ensures you can architect solutions that are both powerful and cost-effective. Our final mind map recaps the core concepts. The central node, Azure Compute, splits into our two focus areas. Virtual machines are defined by IaaS, OS control, and VNet requirements. Azure Functions are defined by being serverless, event-driven, and requiring no infrastructure management. This visual summary captures the essence of this lesson.